Hello again. So as you probably know, I've been doing a few videos on breaking down PET into benzene. And it made me start thinking about what actually breaks down PET. And I realised that the breakdown of PET is actually the #1 cause of lab accidents over the years for me. I see a lot of videos on like starting up a lab and advice you give to people who are first starting a home lab. And they're all very good, but one thing that I think they always miss is talking about storage in soft drink bottles. Now, in an ideal world, all we'd have is the Scotch Durand storage bottles with the red cap or blue cap Teflon lids. I think the red ones are Teflon. Anyway, but that of course doesn't happen. They're expensive. Quite often you're halfway through a synthesis and you don't have enough jars to store the stuff in, and so and when you start out you've only got 3 beakers, so like it's really tempting to think, oh, I'll just do the synthesis in the soft drink bottle. And that happens to me quite a lot, even now still. I think it happens to me more so because in the state I live in, you get a 10-cent deposit if you return the soft drink bottle to a depot. So that means my family just hoards these empty bottles until we take it down to the depot, and at which point we have somewhere between 500 to 800 bottles lying around in a big pile in the shed over there. So it can be tempting when I got no beakers clean and there's 600 empty bottles there that I could just wash out and use. But as we have seen, soft drink bottles are made of PET, which is polyethylene terephthalate, which is a chemical that's susceptible to hydrolysis, so breaking of the ester linkages in there. And in that case, the plastic will break and your things will leak, or you'll start to contaminate the things inside. But interesting thing about PET is that it's quite resistant to some things and quite susceptible to others. And to me, the list of what it can resist and what it can't resist is quite hit and miss. I've got a list of a few things here. So these things that I'm going to read out, these chemicals, they either will permanently damage the PET on contact with it, or be fine for 30 days. So I'll read out the chemical and you've got to commit to an answer here. Is it going to permanently damage the PET, or is it going to be fine after 30 days? Alright, so the chemical is diethyl ether. Will diethyl ether eat through PET? The answer is no, surprisingly. It will be fine in a soft drink bottle, but more than 30 days. What about 50% hydrofluoric acid? We know it eats glass. Will it be fine in PET? Answer is no. That will immediately destroy it. 30% hydrogen peroxide. Fairly dangerous chemical, will bleach skin on contact. Will it destroy PET? Answer is no. It'll be fine after 30 days. What else we got on this list? Chloroform, chlorinated solvent. I think that one's pretty easy. That one would destroy it on contact. What about 10% hydrochloric acid? We know that acids hydrolyze esters, so will it be fine? The answer is yes. It will actually 10% hydrochloric acid will actually be fine after 30 days. There'll be no damage. What about carbon disulfide? It's a very good solvent, very volatile. Will it eat through PET? No. Carbon disulfide will be fine. What about DMSO? That's not really seen much in the amateur lab, but in a proper lab it will be seen quite a lot. Will DMSO be fine in a soft drink bottle? No. And the last one on my list here is methyl salicylate. Oil of wintergreen. Will oil of wintergreen eat through PET immediately or be fine? And the answer is it will eat through it immediately. Okay, so the one thing I want you to get out of this video is that if you're going to use plastic bottles for anything, check the plastic chemical resistance charts online. There's lots of them. Ideally, they'll tell you, like, you look it up and go, oh, is my chemical just going to dissolve the bottle that I put it in? And it will say, yes, it will. And that'll save you a lot of failed experiments and potentially damage. So I guess I'll tell you a few stories now where I haven't checked the chemical plastic resistance charts and I've just gone ahead and it's ended quite badly for me. My first issue with PET storage came quite a few years ago while I was still in high school. In high school we used a lot of standard solutions of sodium hydroxide, like 0.1 molar, 0.01 molar. I was doing a bit of lab stuff at the time and I thought it would actually be quite useful for me to have standardized solutions in the lab for me to use. So I decided, I'm going to make I think it was a 1 molar solution of sodium hydroxide. And I weighed out the appropriate amount of sodium hydroxide. I got a bottle that fit in the drawer, which happened to be a bottle exactly like this one. And I also thought, oh, the lid would be very good as well, so I can, dispense it out, squirt out the 1 mole sodium hydroxide solution. It was quite a few years ago. Just give me a break. I put it in there. Everything seemed fine. And a few days later, it split right down the middle and spilled out. And this is what this scar, I call it a scar, on my bench is from, because the bottle was here and it split and it stripped the paint all the way up here. There was a pot here and it accumulated here and ruined the paint in that section. And it keeps going all the way over there. So like here, all the paint's been stripped off. Just a matter of coincidence, I'm actually thinking of repainting the benches this week. Finally, after so many years, I've never done it before. Which is why the benches look so spectacularly clean at the moment. They're usually absolutely crammed full of crap. So yeah, don't store strong bases in PET, especially sodium hydroxide solutions. They will split it open. There's basically no concentration that's safe. I mean, in saying that, if you're 0.001 molar, you're not going to eat through the PET, but concentrations like 1 molar, it really will destroy the bottle within a few days. This bottle here is filled with concentrated ammonia. It's probably about 25 to 30%. I bought it off a friend who had a big bottle of it and decided to give me a litre of it. I bought it off him. I think it was about a year ago. I didn't put it into this bottle. Neither of us checked the chemical plastic compatibility charts, and we put it in a PET bottle. I started noticing some white building up over the top of it in the headroom of the bottle. And I thought, oh, I know what that is. That's just the ammonia reacting with the hydrochloric acid bottle next to it. So I thought, I'm smart. What I'll do is I'll move the bottle of ammonia into a cupboard away from the hydrochloric acid. Well, it was also out of sight. And so it sat there for a few months. And when I went to get it out, it looks like this. What this has done, the ammonia has hydrolyzed the ester linkages and made ammonium terephthalate. With the bottle. Now the bottle is very, very weak, and I'm lucky I caught it because I think another week or two and this bottle would have split, and it would have spilt a litre of concentrated ammonia in my cupboard, which would have been quite a hassle, quite damaging potentially. And yeah, I think it has split down the bottom here finally. This is empty of most of the ammonia, but yeah, I reckon I can just nearly shred this bottle. As you may, I have complained about this before, but ammonia is my least favourite smell out of everything I smell. So a litre of ammonia spilling is like my nightmare. But it also, I had to filter all the ammonium terephthalate out, but it's hard to get all the dissolved stuff out. So it has tainted all my chemical, even though I've caught it before it broke. So to get to this stage, I think it took about 8 months of sitting in that cupboard. But if it was in there for a week and I put it out, there would have been really of no consequence, but yeah. This bottle here is filled with nitromethane. Now I got this from a store that sells it to like hobby car enthusiasts that use like nitro in the little hobby cars. And so this store, it's just like a service station, and they've just got these huge drums of methanol and nitromethane and a few other things. So you bring your own container and then they fill it up for you, and then they charge you per litre. So I bought a litre of nitromethane. I didn't put it into this container. I put it into a container that looked exactly like this one. And I obviously was buying it with such confidence that they didn't even question putting it into a plastic container. Now I took it home. I was pretty excited with my purchase of a litre of nitromethane. I could make a new explosion fire video out of it. So I forgot to put it into the lab, and I remember putting it on my bedroom floor in my room. And it was fine. I went to bed, woke up in the morning, and in the headroom, so that the solvent level was about there, and in the headroom above, all the plastic was really white, and it was going all white down the bottom. And I realised, oh shit, I have fucked this up. And so I quickly got it and I put it into a glass bottle. And once I had the empty bottle, I wish I kept it. I just threw it out, but it was so brittle around the top where it had gone all white. Because once I tipped it all out, all the clear plastic, I guess, not really on exposure to the liquid, but I guess the nitromethane vapors is what really kills it. Because after I tipped it all out, all the plastic went like opaque and I picked it up and I just put my thumbs through it. It was so weak. So if I had slept in a few more hours, I think that day, the nitromethane bottle would have split. It would have gone onto my carpet and probably ruined like a square meter or more of carpet, because the nitromethane would have just wrecked the carpet. I think even my carpet's made of PET as well. I've got a rug. Yeah, that would nearly ended in a very big disaster. But luckily, I put it in a glass bottle and it's fine. Once again, neither I nor the owners of the store, but I'll take full blame for this, checked the plastic compatibility charts to see if the chemical was actually fine in PET, and it wasn't. Alright, so what do I actually use PET bottles for nowadays? Well, I'll use them a lot for waste bottles. This is stypnic acid waste that I've got to reduce somehow. Same with picric acid waste up there and some shitty bottles. Chlorate waste is in that clear one. Got some iodine waste in there. Those other milk containers are each different metal wastes, like manganese, zinc and lead and mercury and copper. Some more waste bottles down the side here. Looks like cobalt waste. This bottle here is sodium bicarbonate for acid spills. It's not very pure, it's sort of just waste base, but it's good to have on hand. Any dilute acids here are generally in PET bottles. Dilute hydrochloric. This is azeotropic hydrochloric, but it seems to be fine in PET bottles for extended periods. Dilute sulfuric, dilute nitric. Even got some 30% nitric in here. You can see it's starting to do a bit of fuming because the weather's like 35 degrees at the moment. Then we come over here. Generally have no bases at all in PET containers. Come to our flammable straw. Anything that comes in a PET bottle can generally stay there. So that's ethanol, methanol, paraffin oil. The ethylene glycol is fine. Well, that's probably enough of my stories for one video. Let me know in the comments when you've trusted PET plastic and it's failed you. I know a lot of you have amateur labs at home, and you've probably made similar mistakes to me. So, yeah, tell me your best plastic failure. Tell me your best plastic failure story, because I enjoy reading those comments. Anyway, thanks for watching. Oh, how nice is this undercoated paint? Yeah, got some high gloss paint, high gloss enamel paint to put over this. Should be really nice, slick.